continue our chapter 9. Chapter 9, we're going to solve for linear equation more than one variable. It could be 3 or more. Alright, so instead of using addition and elimination method that we did learn from chapter 8, we're going to use matrix, and we're going to use elementary row operation or Gaussian elimination method. So the goal of this is you're going to put them in a matrix, and you can do these three property here. You can interchange any two rows. All right, so the notation is interchange. It look like that. All right, you can multiply a row by non-zero, any constant. So C is the constant times any row, and then you can add a multiple of one row to another. So you can have C R1 plus Rj go to Rj. And then at the very end, and we all gonna do different thing. At the very end, you're gonna have 1 at a diagonal. That's what you wanna do. You wanna have 1 at a diagonal, 0 everywhere else underneath. And then number on the top can be any number, or 0, doesn't matter. And to use this method, it has to be a square matrix n by n. All right, so let's look at our first example. I have this linear equation, 3 variable x, y, z, and constant. So first thing you want to do, you want to line them up. All right, you're gonna have x first column, y second column, z third column, and constant on the other column. If any variable is missing, you're gonna put 0 times that variable. Right? So we're gonna put in matrix. This is 3 by 3. We have 3 variable and 3 equations. So it's a square matrix, 3 by 3. So let's look at the first one. You just take the coefficient. We have 2, 4, 1, and 5. That's your first row. So we're gonna do 2, 4, 1, 5. Look at the second one. You have 1, 1, 1, and 6. So 1, 1, 1, and 6. The last row you have 2, 3, 1, 6, 2, 3, 1, 6. All right. So let's look at this. I'm gonna my goal. I just have to kind of like think ahead what I need. So let's say if I want to have 0 right here. In my mind, I want to have 0 right here. So I'm thinking if I multiply -2 to the first row and add to the second row, if I add them, I will have 0. So let's do on the scratch board. So if you multiply this by -2, so you multiply -2 to the second row. So I'm going to have -2, -2, -2, and then -12. All right, that's 2 times the second row. Now my third row is the same, which is 2, 3, 1, 6. Now if I add them, right, if I add them, I will have 0 right here. That's what I want. That's why I'm doing that. So I'm gonna have 1 here, -1, and then -6. Alright, so my second row will change after this operation. I'm going to have 0, 1, -1, and -6. Everything else, the first row and the third row is the same. So I'm just going to put different color for the one that I just changed. Now I'm thinking, I'm going to change the third row. Maybe I want to have 0 here. So let me write the second row. Second row remain the same, 0, 1, -1, -6, right? I'm just copy this second row over there. Now I want to have 0 right here. I want to have 0 right here. That's what I'm thinking. I want to have 0 right there. What can I do in here to get 0 on that cell? So I'm thinking if I multiply this by -1, all right, and add to this one, I will have my 0 there. So let's do that. So I'm going to multiply the first row by -1. So I'm going to have -2, -4, negative 1, and negative 5. Right? Now I'm going to add to the third row. This is my third row, which is 2, 3, 1, 6. I'm going to add them. Okay, so my first one, I'm going to have 0, negative 1, 0, and 1. So see, I get 0 because I want that. So I'm going to write it here with different color. So 0, negative 1, 0, and 1. So far so good. So see, I have 0 here, 0 here. Remember, I want to have 1 on the diagonal. I want to have 1 on the diagonal, and I want to have 0 underneath. I have 0 here already. I have 0 here already. Maybe if I have 0 here, that's closer, right? To get 0 here, what can I do? I can add these two. I can add these two without changing the 0. You don't want to go back and get some number because you want to keep this 0, keep this 0, keep this 0. So if I add these two and put in row 3, I will have 0 there. So but second row will not change. So I'm going to leave it 0, 1, negative 1, negative 6, all right? Second row doesn't change. But my third row will change. Let's add them, all right? I don't have to write it here, right? We can add right here, yes? So 2 and 3, if I add and put in row 3, 0 and 0, I have 0, I have 0, I have negative 1, I have negative 5. All right, now I have 0 here, 0 here, 0 here. So if I make the diagonal 1, I'm done. And I'm done. So I'm thinking, well, for me to get 1 here, I have to multiply everything by negative 1, then I'll get 1 here, and I still keep my 0, right? So let's keep the second row. 0, 1, negative 1, I forgot the 5, negative 6, all right? I'm just copy it. Now I'm gonna multiply the third row by negative 1 just to get the 1 here without changing my 0. So multiply by negative 1, so I have what? 0, 0, 1, and 5. All right, okay, almost there. I have 0. If I get 1 at the diagonal, I'm done, right? So I'm gonna divide the first row by a half. I divide the first row by 2 and put in the first row. So I'm gonna leave everything else the same. 0, 1, negative 1, negative 6, 0, 0, 1, 5. All right, so divide the first row by half and it's gonna go to the first row. So if you divide this by a half, you're gonna get 1. Divide this by half or by 2. Multiply by half, divide by 2. So you're gonna get 2, 1/2, 5/2. All right, let me check myself if I did it right. That's correct. All right, so now you have 1 at the diagonal. Okay, 0 everywhere under, above the diagonal, let it be, whatever it is. So that is the form that you want. Now we're gonna solve it, all right? So I'm gonna put it back into the equation. So let's erase this. So I'm gonna put it back into the equation. So this is x, y, z, and constant. So you're gonna have 1x, so I can write it as x plus 2y plus 1/2 z equal to 5/2. All right, the second row I'm gonna have 0x, so I don't have to put 0x, right? Just 0. Plus 1y minus c is equal to negative 6. Alright, the next row will be 0x, 0y, and z is equal to 5. Now you have solved for c. You're going to substitute c back in here to get your y. Alright, so you're going to have y minus 5 equal to negative 6. So y would equal to negative 1. Alright, now you have y and c. You're going to use both of this, substitute it back to the first one to get the last one, which is x. So you're going to have x plus 2, y is negative 1, plus 1/2, c is 5 over 2. Right? So let's simplify this. X minus 2 plus 5 over 2 equal to 5 over 2. So if I subtract 5 over 2 from both sides, then I have x minus 2 equal to 0. So x equal to 2. Alright, so it's one solution. The graph cross at one point, and the point is 2, negative 1, and 5. That's the solution set. So it doesn't matter, alright, if you have 10 by 10, you just keep substituting back. Then you get all the variable that you need. So it's help in the sense that if you have more than 3 variable, you have 4, 5, 6, or 7, or infinite, you just keep substituting back. Alright, so I'll see you next section.